Hello GATE aspirants, welcome to part 14 of GATE Nuclear and Particle Physics series. Question number 23. A 60 cobalt nucleus emits a beta particle and is converted to 60 nickel with Z pi is equal to 4 plus, which in turn decays into 60 nickel ground state with Z pi is equal to 0 plus by emitting 2 photons in succession as shown in figure. Which one of the following statement is correct? And these transitions are given and we have to identify whether it is electric or magnetic transition. First of all, if parity changes, and the change in delta L, if it is 1, then it is an even transition. So if parity changes, then the transitions are E1, M2, then we have E3, M4 and so on. And if there is no change in parity, then these transitions are, this first transition will be M1, then this will be E2, then M3, E4 and so on. And for this delta L is 1, 2, 3, 4. So check first delta L, see if parity is changing. If parity is changing, then it will be E1. If parity is not changing, then it will be M2. This one is dipole, this one is quadrupole, and this one is octopole. So we have to just check that. Now for first transition, 4 plus goes to 2 plus. In option, 4 plus goes to 2 plus. That means this delta L, it can have values from Zi minus Jf to Zi plus Jf. So that will be 4 plus 2 is 6 and 4 minus 2 is 2. So it can be 2, 3, 4, 5 and 6. These are the possible delta L values. And parity is not changing. So there is no change in parity. So that means these transitions can be, parity is not changing and this is delta L. So it can be E2, M3, E4 and so on. All these transitions are possible. For the second case, 2 plus goes to 0 plus. So here delta L is equal to 2 minus 0, 2 plus 0. So delta L is equal to 2 only. And delta pi, so there will be no change. Parity is not changing. So here transition is E2 transition only. So E2 means it is electric quadrupole transition. So option C is correct. And 4 goes to 2, it is, first it is electric quadrupole or then magnetic, so it is not that case. So only option C is correct here. So answer is option C. And one more thing, if delta L is equal to 0, then there will be no transition. Next question. The Hyperon 0 star particle is a member of Baryon decouplet with isospin state I3 is equal to half-half, the strangeness quantum number -2. In the quark model, which one of the following is the flavor part of this wave function? Now here it is given that I is equal to 1 by 2 and I3 is equal to 1 by 2 and strangeness number is -2. So that means its quark composition has to have S there. So S2S will be there. So its quartz composition can be USS. Now this is a flavor part. So flavor part is always symmetric. So add this. So second possible case is SSU or SUS. And then we have to divide by √3. So this will be the flavor part. So option B is correct. Also you can check charge Q. What will be charge Q? It will be U 2 by 3 minus 1 by 3 minus 1 by 3 is equal to 0 and total charge is 0. Also Baryon number is 1 by 3 plus 1 by 3 plus 1 by 3, that will be 1. So it is a baryon. Flavor part is symmetric and color part is antisymmetric. Option B is correct. Next, the deuteron is a bound state of neutron and proton. Which one of the following statement is correct? Option A, the deuteron has finite value of electric quadrupole moment due to non-spherical electronic charge distribution. This is correct. So this finite value of electric quadrupole moment is because of that 3D one state. Then the magnetic moment of deuteron is equal to sum of the magnetic moments of neutron and proton. Also their coupling is considered. So B is not correct. Option C, the deuteron state is an admixture of 3s1 and 3d1 states. This is correct. Option D, deuteron state is admixture of 3s1 and 3p1 state. So here option A and C are correct. Next question. The Geiger-Müller counter is a device to detect alpha, beta and gamma radiations. It is a cylindrical tube filled with monoatomic gases like argon and polyatomic gases such as ethyl alcohol. The inner electrode is along the axis of cylindrical tube and the outer electrode is the tube. Which of the following statements is or are correct? Statement A. Argon is used so that ambient light coming from the surroundings do not produce any signal in the detector. Is correct. Ethyl alcohol is used as quenching gas. Correct. The electric field strength decreases from the axis to the edge of the tube and the direction of field is radially outwards. Correct. The electric field increases from the axis of the edge of the tube and then the field is radially inward. No. So here option A, B and C are correct. Next question, 48. In a hadronic interaction, pi0 mesons are produced with different momenta and they immediately decay into two photons. So pi0 is created and then immediately decays into two photons with an opening angle theta between them. Assuming that all these decays occur in one plane, which one of the following figure depicts the behavior of theta as the function of pi0 momentum p? So consider its momentum is p and then it is going to decay in two parts. And this opening angle is theta, so this will be theta by 2 and this will be theta by 2. Let their momentums be p dash and p dash. Now for conservation of momentum, we can resolve this p dash into two components. This will be cos component. So p initial momentum will be equal to final momentum. So that will be 2p dash cos of theta by 2. Also consider energy conservation. So initial energy will be, that will be momentum. So that will be p square c square. Pc is with the momentum, energy due to momentum, kinetic energy, plus mass energy. So this will be mass, let it be m pi. So this will be m square c raised to 4 and square root of this. So this will be initial energy and final energy will be these two. Now photon is massless, so only energy will be because of its kinetic energy, and kinetic energy is p into c. 2 times we have to consider because there are two photons. So 2 p dash c. Now let us solve this. So this will be p square c square plus m pi square c raised to 4 and that will be equal to 4 p dash square c square. Now from here, from this first equation, we can calculate p dash square p square. So let us multiply c square on both sides and take square first. So this will be p square is equal to 4 into p dash square c square into we have cos square theta by 2. So this will be 4 p dash square c square cos square theta by 2. This will be cos will be sec here. I am substituting for p dash c dash square here. So it will be here also p square. So I am squaring and multiplying by c square. So this will be p square c square and this will be 1 upon cos square theta by 2, that will be sec square theta by 2. Okay, so this will be p square c square plus m pi square c raised to 4 is equal to p square c square and in bracket sec square theta can be written as 1 plus tan square theta by 2. So this p square c square it will cancel out and you will get m pi square c raised to 4 is equal to p square c square into tan square theta by 2. So this c square will cancel and P is equal to, throughout we can take square root, so m pi c square is equal to Pc into tan theta by 2. So P is equal to, Cc will cancel, so this will be m pi c into cot theta by 2. So this is the expression for P, which we have to plot versus theta. So now if theta is going to be 0, then P will be infinity. And if theta is pi, then that means P is 0. So it means it will be a hyperbolic parabola like case, and which is matching to option A only. Next question. Under parity and time reversal operation transformations, which of the following statements is or are true about the electric dipole moment P and magnetic dipole moment mu? Now, electric dipole moment P is equal to summation over Qi Rr. And if parity operator is operated on R, then it will change its parity, so it will become minus R. So this P will be summation over Qi, so this will be minus of Ri. That means it will be minus of P, so it is odd. Similarly, magnetic dipole moment is equal to minus EL by twice M. And if L bar is operated with time reversal, so time will be reversed. L is equal to mvr, V is equal to dr by dt, so their time is there, so it will change its sign. So mu will be minus of E by twice M, and here we will have minus of L, that is minus of mu. So again it is odd. So it is P is odd under parity and mu is odd under time reversal. So option A is correct. Next, a slow moving pi particle is captured by a deuteron in this reaction, and this reaction produces 2 neutrons in the final state. So this is given, pi minus plus deuteron gives neutron plus neutron. Neutron and deuteron have intrinsic even intrinsic parities. So parity is plus, plus, and for deuteron as well plus. Whereas pi minus has odd intrinsic parity. So this is odd. L and S are the orbital and spin angular momenta respectively of the system of 2 neutrons. Which one of the following statements regarding the 2 final neutron state is correct? So these are the parities, and parities will be conserved. So this will be minus 1 raised to L. So I'll get this minus 1 plus 1 minus 1. This will be the case. Plus and minus 1 raised to L. So I'll get minus 1 is equal to minus 1 raised to L. That gives us L is equal to 1, or it can be 3, or it can be 4, and so on. So L will be odd. Now next part is it has odd parity. So option A is correct. It has odd parity. Then we have to consider L plus S as well. So let us calculate spin here. So we have pi minus plus D gives N plus N. Neutrons are spin half particles, so half half. Deuteron is spin 1, so pi minus 1 has 0 spin. So here, for this state, for this 2 neutron state, S is equal to 1. And also we have L is equal to 1 from here. So S is 1 and L is 1. So L plus S, it will be E1. So this is not a case, and this is also not a case. So here option A and C are correct. Next question. In pion-nucleon scattering, the pion and nucleon can combine to form a short-lived bound state called the delta particle. So this is the reaction. The masses of pion, nucleon and delta particle are given. In the lab frame where the nucleon is at rest, what is the minimum energy of the pion to produce the delta particle? So if we have a reaction like this, AB gives C plus D, if this is the case, then the threshold energy of A to produce C and D particles is given by this expression, minus Q in bracket MA plus MB plus MC plus MD the whole thing divided by 2 MB. This is for calculating threshold energy of a particle, where this Q is the Q value of this equation. So we have this equation, let us calculate this. So we have Q is equal to, Q is mass of reactants minus mass of product. So this will be pi, for pi particle it is 140, for neutron it is 938 minus 1232 into mega electron volt by c square into c square. So this will be mega electron volt, and 140, this will be the Q value, and this comes out to be minus 152 mega electron volt. Now threshold energy of pion, so this is threshold for TH, threshold energy, it will be minus Q into addition of all these masses. So this will be m pi plus mn plus m delta upon we have 2 into mn. So this will be minus of 152 into addition of all this. So this will be 140 plus 938 plus 1230 upon we have 2 into 938, and this comes out to be 187 mega electron volt. So it is threshold kinetic energy of that particle. So total energy will be A pi is equal to this kinetic energy plus mass energy. So m pi c square, and that is 187 plus m pi c square is 140. So this comes out to be 327 mega electron volt. And the answer given to this question in answer key was 326.9 to 327.1 mega electron volt. Next question. An alpha particle is emitted from the decay of americium at rest, that is, this equation is given, and rest masses are also given. What is the kinetic energy of alpha particle? So first calculate Q. So Q will be mass of reactants minus mass of products into C square. So this will be 224.56 minus 220.811 minus 3.728, this whole thing into giga electron volt, and this is equal to 0.005 giga electron volt, so that is 5 mega electron volt. Now kinetic energy of alpha particle is equal to A minus 4 upon A into Q value. So this will be 241 minus 4 upon 241 into 5 mega electron volt, and this is equal to 4.917 mega electron volt. Rounding off to 2 decimal places, this will be 4.92 mega electron volt. And answer to this question given in the answer key is 4.90 to 4.92. So these were all the questions from GATE 2023 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.